Hello everyone, today we're going to be looking at the structure of the atom. So first off I'm going to show you what an atom looks like and how you should draw it. So first I'll start with a proton, which I'll put a little plus inside, and some neutrons. So this is the nucleus that contains the protons with the plus inside and the neutrons, which are neutral. And then there's an electron shell, which has electrons shown by little crosses. And the first shell starts off with 2 electrons in it, and that's what fills it. And then the next one can have up to 8, and the next one can have up to 8, and the next one as well can have up to 8. But you'll only learn the structure of 2, 8, 8, 2, because you only have to draw up to 20 for the atomic number, which is calcium, just here. It's got the atomic number of 20. Now the atomic number is the number of protons. In each atom. And this shows us which element it is, because it's different for every single element. And as you can see on the periodic table, it goes from 1, 2, 3, 4, 5, 6, and so on. And these, so hydrogen will have 1 proton in its nucleus. Helium has 2 protons in its nucleus, lithium has 3, and so on. And it also will equal the number of electrons, and this balances the charge. So the same number of protons, which are positively charged, and electrons, which are negatively charged, to give an overall neutral charge. Okay, and so the charges of each particle inside the atom are, for a proton, it is +1. This is to show it's positive, and it's got to be written as +1. And the relative mass compared to carbon-12, which is an A-level thing, you just need to know it's a relative mass to other atoms. The relative mass of a proton is just 1. And the charge of an electron is -1, as it's negative. And the electron is much smaller in mass. And it can be written as very small. Some exam boards accept just very small, some accept, or all of them will accept 1/2000, which is rounded up from 1/1836. So I'll put 1/2000 in here because I find that easiest to remember, and all exam boards should include that in their mark scheme. So the charge of a neutron, because it's neutral, is just 0, and the relative mass is the same as a proton, and it's 1. Oh, and the mass number of an atom is the number of protons can't spell plus the number of neutrons. So you can then find out how many neutrons there are by taking the proton or atomic number so you can take the mass number and take away the atomic number, and that will equal the number of neutrons. So I will get rid of this incorrect example that showed you how to draw the atom, but it did not show you any specific element. So I'll draw oxygen as my example. So it has 8 protons, and 16 minus 8 equals 8, so it's also got 8 neutrons. And this is in the nucleus. Just write a little plus. Okay, and then the electron shells. So the first one has 2. There are 8 electrons as well because there are 8 protons. So the first one has 2 and the next one will have 6 because that adds up to 8. So you draw them on as crosses, and you do one on each side, and you then pair them up, so that is 6, and you systematically pair them up as it looks neater, and that's generally how you'll see them in exams. Okay, so the nucleus is this here. This is just labelling the diagram. This is a neutron. This is a proton. This is an electron. And this is an electron shell. Okay, and in the nucleus, as the protons and the neutrons have a much higher mass than the electrons, the nucleus then is very dense, as it's much smaller than the rest of the atom, and it has the majority of the mass. And this means it's very dense and the mass is very concentrated. Okay, so that is the notes for the structure of the atom and how to draw it. And the next thing we're going to look at is an exam question. So I'll say pause here and let you have a go at these questions. Okay, so how you do this is lithium, you need your periodic table. Lithium is here, so it has a relative atomic mass of 7 and an atomic number of 3. So we can write this as that there. So the mass number is 7. So you tick that box. And the charge of an electron, as I just told you, is -1. Okay, and then there's another couple of questions. I'll let you do them as well, and then I'll go through it. Okay, so hopefully you've done these two. And so, protons are in the nucleus. Which other subatomic particles are also in the nucleus? Well, as I told you earlier, protons and neutrons are in the nucleus. So I'll put a tick in that box. What is always different for atoms of different elements? Right, so that is the number of protons, because the number of neutrons changes for the different mass numbers, and some can have the same mass, some can have the same neutron numbers as each other, but all of them have different proton numbers. So, proton. And here's the next one. Zoom out a bit. Have a go at that, pause it, and then I'll go through it. Okay, hopefully you've gone through that now. And I'll tell you what I've got. Okay, so these atoms are elements in the second row of the periodic table. So the second row is lithium, all the way to neon. Okay. Which atom is from an element in group 3 of the table? Right, so this is actually ahead of what I've taught you just now. But I'll tell you what are the groups. So the groups are shown at the top here. So that's group 1. These are columns. And these are the rows, which are called periods. So this whole line is period 2, because this one here is period 1. But we're looking at groups. So we're looking at group 3. Group 3 is just here, and it tells you in the periodic table. So boron is the one that's in period 2 and group 3. And boron has a proton number of 5, so we'll have a look at which one has 5 proton number. Okay, so that is atom Y, because the proton number equal to number of electrons, and there are 5 electrons here. So it is Y, so tick that box. Okay, so the next question. Figure 3 shows the electron arrangement of different atoms from an element in the second row of the periodic table. Okay, so this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. Okay. Right, so the second row. Which is also the second period, as I was saying. And so if it has 10 electrons, that means it will also have 10 protons. 10 protons. And let's find out which is in the second period with 10 protons. Here we go, neon. So it says give the chemical symbol, so that will be Ne, as it is here. I will rub out bits around it, just highlight that for you. So that's Ne right there. why is this element unreactive? So this element is unreactive because it has a full outer shell of electrons and does not want to gain any more. It has a full outer shell of electrons. So this question here hasn't been covered by what I've told you today, but you will see it in the future. And we'll just check this through. So my answers were 7, okay, 7, here we go, because it was question 2. 7 minus 1 neutrons, 7 minus 1 neutrons, and then number of protons, atom Y and Ne, or you could actually have neon. Okay, number of protons, atom Y and Ne, or neon was accepted. But I would say if it asks for the chemical symbol, always just put Ne for neon. And then the last one has a full outer shell. But you can also say allow in group 0, as it's in group 0, just there on the periodic table. Full outer energy level instead of outer shell. You can have the shells are full. Oh, and it's a noble gas, which is the same as saying it's in group 0. And it has 8 electrons in its outer shell, which is the same as saying it has a full outer shell. Okay, so we'll now move on to the development of the structure of the atom. Right, so this started off in 460 BC, so an extremely long time ago, from a Greek philosopher called Democritus, who said all matter, including space and time, was made up of small units named atoms. So this is where the word atoms came from. And it's amazing to think that long ago they had an idea of what everything was made up of, well before science was as big as it is now, and way before any sort of scientific testing was around. Okay, so the first atomic theory was made by Dalton, called the Billiard ball model. Now this is because it's basically in the shape of a billiard ball. And Dalton suggested that atoms are tiny spheres that can't be divided. And these are invisible particles. So they're so small that we cannot see them. And all atoms of one element are the same as each other. But all atoms of different elements are different. And then he said that compounds are formed by combining different atoms, such as if you combine oxygen and oxygen, you get O2. Okay, so the next theory came about in 1897, so quite a bit later on than Dalton's, and this was an improvement on Dalton's theory, where J.J. Thomson came up with the Plum pudding model, and this is where he discovered electrons as negative charges within the atom, and suggested that there was also a positive charge with the negative electrons embedded in the atom. And it's called the Plum pudding model because the raisins in a pudding, like this here, look slightly like what he was suggesting, all embedded inside the atom, or inside the overall cake. Next was Rutherford model in 1911. He discovered the nucleus and the protein. The proton. I'm getting biology mixed into this. He found, using his gold leaf experiment, which we can talk about later on in this topic, that atoms have a positive charge in the centre and are mostly made up of empty space, with electrons orbiting randomly around the nucleus. And this positive centre is the nucleus. The next model came about in 1913 from Bohr, called the Bohr model. And this is where Bohr had adapted Rutherford's model with his findings of electrons orbiting at a specific distance from the nucleus. And this made a much more structured sort of atom model. And he proposed that electrons moved in shells, which are shown in this here. And every atom has a specific number of electron shells, which is again the 2, 8, 8, 2 configuration of electrons in their shells. And Chadwick discovered neutrons. He did this by measuring masses and found there are particles with no charge in the nucleus with the protons. In the nucleus with the protons. And so that's about all you need to know for the development of the structure of the atom. I hope you've enjoyed this lesson. Hopefully it wasn't too long, and come back for another one, I guess. And learn more about the atomic structure, and we'll do some mixtures and some more on isotopes and lots of other exciting things, and then we'll do the periodic table and how that came about as well. And yeah, so see you next time.